Alright, question 7. So this the diagram shows three coplanar forces F1, F2, and F3 which acts on a point O here. So we have to find Fx, which is the sum of the components of the forces along the x direction, Fy, the sum of the components of the forces along the y direction, and lastly the magnitude and direction of the resultant force. Okay, so question A. So we are looking for the x component, right? So if you prefer doing it in a table, you can do it in a table. If you don't, you can just do it as how I'm doing it now lah. So for forces, force 1, the x component is equal to F1 cos 30 degree. Okay, sorry, let me just redo that. So the total force at the x component is equal to F1 cos 30 degree minus F2 sine 40 degree, and for force 3 it is minus F3 cos 55 degree. Okay, so let me explain. So F1 cos 30, I hope you are able to understand why is it cosine 30 degree. It is because the angle lies on this x-axis. Okay, and then for force 2 pula, why is it sine 40 degree is because this 40 degree is not on the x-axis, it is on the y-axis. Okay, and same thing goes for this one lah. Okay, so from here we will then get 6.9 minus 3.9 minus 2.9, which gives us 0.2 Newton. Okay, and then for let me just double check. Yeah, okay. So now for question B pula, for the y component, this is total force at y. That's gonna gives us, for F1 it is gonna be F1 sine 30 degree. F2 it is gonna be plus F2, sorry, not sine, cos 40 degree, and F3 is gonna be minus F3 sine 55 degree. Okay, it's usually gonna be different for x and y component. It's not gonna be the same. Okay, so this is gonna be 4 plus 4.6 minus 4.1, which is equal to 4.5 Newton. Okay, so that is A and B. Now for the magnitude of the resultant force, you're just gonna use total force equal to total force at component x and y. So this will give you 4.5 Newton. Okay, and then the direction of resultant force, again you will just use shift tangent Fy, Fx. This is the total. Okay, so this will give you 87 degree, which is above the positive x-axis. Okay, why is it above the positive x-axis? It's because the force at component x and y are both positive lah. So that is in this quadrant here. Okay, so that is your solution for question number 7.